Well, hello there and welcome back to another video. Hopefully the last installment of this series on Advent of Code 2021, day 24. A very challenging puzzle. It's about, well, the dreaded monad challenge, I guess, where you have to interpret some weird code and find a number. So this video doesn't make any sense if you haven't watched any of the previous videos on this series. So basically what we have is a working solution, but a very ugly one. And in this video I'd like to do two things basically. One, I would like to understand why we had a problem with non-deterministic execution in the last video, I guess, in the last session. So we have some hashes here that for some reason, if we don't accumulate some results into vectors and sort those vectors, we get like non-deterministic results and we get wrong answers. So I don't understand why that's happening. So would like to understand that, and most of all, I would also like to refactor this code so it's not as messy and terrible as it is right now, because, well, right now this is one of the ugliest pieces of code that I have ever written, and I actually feel pretty proud about having been able to get to a working solution, even though it required writing this mess. But yeah, I would like to leave it in a better state and also printing less garbage, because now when you run this thing, it prints a lot of garbage. So it should just print both answers. And actually right now, this is only computing the answer for part 2, because I have some local changes. That's where we revert, basically we reverse the order of iteration in most of these things, and we reverse the sorted arrays and blah, blah, blah. And with that, we go to, instead of the highest possible number, we go to the lowest possible number that is valid for this so-called monad program. So yeah, that's what I like to do in this session, hopefully. Let's first of all revert these local changes to have answer to part 2. Actually, before that, maybe I can run this. I think this is the solution. This number is the solution for part 2. So let's copy this. Look at that. This is now the full 2021 Advent calendar. It's really beautiful. So on day 24, was my solution this thing? Yes. Part 2, this is the answer. So I think I would like to put that, save that on a file so we don't have to check again and again. So let's put this into day 24 answer txt. Okay, and also let's revert the changes. Look at, no, not that. The changes on the solution. Yeah. Run this thing again and save the answer for part 1 also. So part 1, this is the answer, I think. Let's check, yeah. So let's go to answer, paste it here. By the way, we can also take a look at these things, what they are similar and what would they differ on. What am I missing here? What is the difference between this and this? Why is it finding only one? Am I tripping? Ah, no, here's a 1. I confused the 1 and the 7. So one thing that we can see is that some of these numbers match, of the digits, but not many actually. That's interesting. And it's also interesting that the lowest number is also a very high number, like it starts with 9. And our solution didn't seem to take longer to compute one or the other. So I'm guessing that like more brute forcey solution could take a whole lot of time to get to here, whereas maybe the first one could have been brute forced. So that's interesting too. I didn't have the patience to have the part 1 brute forced, although it could probably have been done in this computer. Anyway, what did we want to do? Yeah, understand why the non-deterministic order of execution. But before that, I think I will make a commit with this hellish solution as it is. Yeah, just to, you know, prevent losing it in a stupid way. Add the super messy day 24 solution. Okay. So about the non-deterministic thing, what we added to prevent that, so we are basically processing this file in chunks. And in the first chunk we are processing 4 of the 14 inputs. This should be deterministic in their order, because this is just 4 loops over normal ranges. So unless, yeah, that is deterministic. I don't want to question that. But we are accumulating things in this hash map. And that's the thing. Then this hash map, the order of iterating that is non-deterministic. And wait, where did we? Did I remove the? No. We're not sorting the first. That's interesting. We are not sorting the first hash map, and this still works. Weird. Okay. That's kind of weird, actually. For the second hash map, so I thought that order of execution shouldn't have mattered, because we are supposedly saving the, basically these hash maps have a set value. Set has to do with variables, so yeah, I don't want to repeat myself from previous videos. And the inputs for that lead to that set value. And when we have collisions on the same set for different inputs, we should be keeping the largest inputs. So if the inputs that we have now are greater than the current value in the hash, we replace the current value. This should be the same as using the max function, but for some reason, well, I think this should be the same, but I don't know what is failing here. So let's maybe remove this accumulation into vectors. So these vectors, are vectors of these things. What happens if we say, hey, you turn into an iterator? And now these things are collecting copies. That's good. And now here, I want to do that to avoid this sort of referencing here. And let's do the same for this into iter. This should be a problem here. Yeah. And that should still work the same, right? There's no difference. But with that change, I think if we now remove, for instance, this, things like the variable, this is a shadow of the previous variable. So if I now remove this vector, sets2 should be still the hash map, and it should now depend on the order of iteration of the hash map. And if we run this, do we get unpredictable order? Yes, we actually do. Remember that before the numbers started with 99, and now we have 95. And if I run again, 93, and so on. So yeah, this is already enough to trigger that. Now the order of it, like, it's nice that the order of iteration of hash maps is not deterministic. And I don't know if Rust actually uses some, I guess it probably is using some random state to randomize that order or randomize the hashing. So each time you run the program, you get different iteration orders so that you can catch this kind of bugs early on, like they explode more on your face. But what I don't understand is how that affects, because we are iterating over all of these values and over all of this and this. We are never early terminating or anything in these loops. And when we, oh, did I keep the inserts? I think I just cut the bug. This code of entry and modify or insert was supposed to replace this insert, but we are unconditionally inserting. so we were always overriding the previous values. Okay, I think that was the bug probably. This no, this was said. Here we are iterating over, like accumulating over sets 3. I wanted to do this over sets 2. Oh, but here we don't have that. Here we don't have that insert unconditionally. Well, this is definitely a bug. Was this the bug? The first one, it's okay to do insert here. This one only does entry and modify. And now this also does entry and modify. And the last one, I guess it also does this, but yeah, it doesn't matter. The last one, we are not even paying attention to that. So if we run now, what do we get? Okay, now we did get 99, blah, blah, blah. It was a very stupid bug. Is this the answer? Yes, that is the answer to part 1. Okay, so that was the problem with non-deterministic results. It was just that I was overriding things in the order that they were being iterated, and instead of doing this actual logic. And by the way, this logic, so now we don't need to do this with this array, with this vector, sorry. We shouldn't need this either. this should still give us those results. Yeah, we can have this search over here, so we know that we are getting the correct answer when running. That's good. And what else? Was there something else that I wanted to get rid of? Yes, I guess this, well, this if condition is the same as saying, hey, this thing max with v. I should probably do this, yes. Does that make sense? I think it does. We don't need the if condition here. Still super ugly, but a bit better, I guess. Same thing over here. Okay. If we run again, we are getting the same answer. That's good. So this is basically still the same answer, the same original answer. So let's add these changes and do an amend. That's just a git alias that I have. Okay, now for the fun part, refactoring this mess. How are we going to do this? So, okay, we should go by parts, I guess. We have the input here. The first thing that I would like to do, I could also get rid of this old solution and commented code. We don't need that. Yeah. Let's go ahead and comment everything and sketch out what I would like to do. So first things first, we have the program. I guess this is still something that I want to do. And for the input, we are going to do include stir of inputs day 24. This is going to be the whole program. Fine. But I would like to split this program into the chunks that are basically each of the inputs plus all of, like, this would be one chunk until the next input. And then I think this kind of code that the logic that we did here, where we are getting like chunking in a more coarse way, I think we can probably do it block by block. I would call each of these things blocks. So if we do, hey, program split, to get all of those splits, I think there is split inclusive, is what I want. So an iterator over subslicer separated by elements that match predicate. The matched element is contained in the end of the previous subslice as a terminator. I don't want it at the end. I would like it at like the beginning. But can we change that? What other splits are there? Split first. What does this do? Interesting. So if there is no nice split to do here, split last mute, can probably, I guess I could reverse this thing and then use split inclusive and then reverse each of them of the chunks inside, but that doesn't seem very good. How else can we do this? I guess we can do it also with a loop. Good old for loop. And an accumulator. So how would we do that? Like we could read the first thing and then do something like take while until we read another input. And that would be it, I think. And well, then continue doing that until we have no more inputs. Yeah, I guess so. It is kind of ugly, but sure. In fact, that isn't that some sort of reduce or fold? Actually, iter. What was the difference between reduce and fold? So reduce returns an option of the thing, and I guess fold takes an initial value. Yeah, beautiful. Does the signature of this thing allow you to modify the accumulator? Where did I... Where am I? How is this Rust code? Iterator, macro. Wow, this is kind of magic. Okay. Yeah, okay. That is something. Let's fold this, I guess, into a vector. This will be blocks. And here we are going to have blocks and what? And instruction, I guess. Right. It takes 2 arguments, okay. vector of unknown things, and basically what we want to do is, if we read an input, we push a new vector of something like this. If say matches, the instruction matches instruction input of whatever, then we are going to push a new vector with that instruction, I think. And actually here I probably want to consume this program and say into iterator. So these are actually instructions, and push found units type. Else we're gonna get the last. Assume there is a last. Well, expect it to be a last. A block of instructions should exist. And in that last one, we're gonna push our instruction. Does that make sense? And then we have the blocks. This okay, I have blocks, cannot mutate immutable variable blocks. Huh. But can't it be mutable? I mean, what if I give you a mutable variable? Blocks then is a mutable variable. That's nice. But that complains. What does it complain about? What are we doing here? This is a block, basically. Why is it behind? Cannot borrow this as mutable. You don't have problem with this. Oh, it's a mutable variable to a reference of. Can I do this? Not really. Cannot borrow. It's mutable. Now seems to be the. Oh, I know. This should be last mute. That's correct. Okay. Sure. Now it probably still works by if I inline this, yes. Okay, now blocks should have what I want. Can we, I don't know, print line? I doubt that this will be very readable, but let's see. Can I actually print that? What? Creates a temporary value which is freed while still in use. Sure. So yeah, the fold here is not very useful. Not very useful, really. What we can do is probably use just more traditional local variable here and a more traditional loop. So for blocks, now for instruction in into iter, yes. Yes. And this needs to be immutable. Okay. Now, kind of messy, but we do have an array, a vector of vectors, and the first thing goes up to, well, let's look for a closing square bracket. So yeah, it goes from input W up to add Z and Y. So that seems correct. Yeah. Okay. So this is our manual version of like that split inclusive thing. It's all right, I think. So now I want to go over each block of code and basically do a general version of what we were doing before, trying all the possible inputs for that block. And well, basically I also had to not hard code this kind of conditions that we had before, because these conditions we reached them by looking like eyeballing the results and seeing like, okay, when the division by 26 occurs, these numbers fall below 5,000, and if it doesn't occur, they fall above. So that's how we split those things. But we're gonna have to be more general in this case. So one thing that we need to do is to detect if we are either in the case where set is divided by 1 or divided by 26. So we could read into the block if we have those instructions. I guess that's one way of doing that. Or we could also do something more clever, I think. I'm not sure. Let's sketch this out. So we're gonna do for, well, block in blocks. We can probably consume it. What are we going to do? Gonna try each input, that's for sure, but we also need some sort of accumulator hash map or something like that. I don't know if I want to use a hash map, but maybe first I would like to like copy this approach into a general loop, try to reach the same answer, and then simplify if possible. So, and these values of Z have to carry over each iteration of these blocks. So we're going to have something like let mutable sets or sets sets and inputs, I guess, would be, but let's call it sets or Z's. This would be hash map. And what do we want to do with this? We probably want to initialize something. Z starts at 0 and we have no input before that. Probably want to start at something, but let's sketch out. Yeah, because we are gonna want to accumulate here like all the possible sets that could be after the execution of this block that we consider that are promising, with all the possible inputs or the maximum or maybe maximum and minimum inputs, something like that if we want both answers. Yeah, I think something like that sort of makes sense. How do we discriminate if this block is one that's we have to, because like in the blocks that divide by 1, on those ones, I basically want to do a cross product. Like I want to try for all the possible sets that we have accumulated, I want to try all the possible W inputs, 1 to 9. Run that block and do an accumulation of sets again, I think. And right? Something like that. Does that make sense? I think so. Does seem all the inputs from before. I'm getting a bit dizzy thinking about this. Yeah, okay, yeah, those two cases. So let's try to discriminate between those two cases. I think they are pretty different. And when we do a div with 26, in those cases, the logic that we want is not like a cross product. We want to do some elimination for all of the possible sets that we had. I want to keep, like try out all the inputs, but only keep the inputs that make that set go down. I think that the accumulated set has to go down. And if it doesn't, we should not accumulate that input. Yes, I think that sort of makes some sense, I think. Okay, so what are we going to have in this hash map? I'm not sure if I want, well, hash map. The keys are going to be set values, so this is easy. But the values, I don't know if I want vex of the inputs or just have a static array of the 14 possible inputs. Probably Let's use a vector for now. Though I don't know what will be easier, to be honest. So yeah, this thing. How do we discriminate between those two types of blocks? One possible thing to do is to try all the inputs with a starting value of Z and see if we get a decrease of that Z. Right? That sort of makes sense, I think. Let's try it. Let's try it and see. For W in 1 up to 9, what we are gonna do is run the loop program of this block. This block now, what is this? A vec pass a reference. The input is just this W. That we have this debug thing. There's a lot of things we can refactor here. And initial variables should be, well, nothing for W. Only the Z is what we want to change here. I actually don't know what. Well, let's pass 0 and see what happens. Let result be this. And then, yeah, okay, we want to see if Z ends up being 0, I guess. So let's have a boolean. Let's mutable boolean is how do we call these blocks that can reduce Z start at false, and if the result Z value is 0, then can reduce Z is going to be true. Let's enumerate this actually. Yeah, we can use iter. Why not? Enumerate. And if we use that, we can just pass the block instead of taking the reference. Yeah, it can be I, whatever. We can print line block I can be reduced, can reduce Z, can reduce Z. False, 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 false. We did something wrong. This is probably because we need some accumulated value for Z, which I don't know what to put in here. Let's try any magic number like 10. And let's see if, yeah, okay, now we have some truths in here. And I think if we go like from like 0 to 26, we're probably going to cover all of them. So if we say, hey, for Z, 0 to 26, because the pseudocode of this is this this is a constant that can be negative. Instead of 11, let's call it C1, and this would be C2. This is a constant. And if it's negative, this is set more 26. So we don't need to go beyond 26. And if this is negative, I think negative 14 or something like this is the highest that we have. We want to check this. And the lowest is like negative 8, for which yeah, I think that also would work if you have a reminder of, I don't know, 9, and then you have -8. Yeah, I think this makes some sense. We should see, hopefully, 7 trues and 7 false, but this looks like more false than true, and the last one should be true for sure. Oh, because we are not using this set. So this should be set, the initial set. Okay, yes, we have 1, 2, 3, 4, 5, 6, 7 true blocks and 7 falses. That's good. So with this we have detected if this block can reduce set. And I think that is the main condition that we have to pay attention to. So if it can reduce set, we are going to do something, and otherwise we are going to do something very different. So what are we going to do? I think that actually in both cases we are going to iterate over all these set values that we had and that we need to initialize, and we are also going to iterate over the inputs. So maybe this if is something that goes inside those conditions. Let's initialize this sets insert the initial set. It's going to be 0 with no previous inputs. Okay. And I actually think that this is probably expressible as from iter 0 vec. Does this work? Yeah. Nice. So we're gonna do for set and previous inputs in sets iterator. What do we want to do? Well, we want to try all the possible inputs for W in 1 up to 9. We're gonna do basically this same thing, I think. Which seems a bit redundant, but whatever. This is just to get this condition of can reduce set. We can probably extract this into a function and it will be hidden away. So we do the results. We get the result. Of this result, This is basically the initial set that we want. I wanted to rename this result to something, you know, better. We can even have something like new set, or just set. And this set is something else, and this can be the initial set, or set 0 to use more of a math notation. Yes, more mathy. And in this case, we want to do previous input. This would be actually the previous set, which we are going to dereference here. And from the results, again, we just care about the set value. So now comes the fun part. If can reduce set, if it can reduce set, it's going to be one thing. Else, let's think first of the case that we cannot reduce set. So what are we going to do? I think in each of these block iterations, we actually want to accumulate an entirely new hash map for sets, I think. So basically what we want is going to be that new sets hash map new, and then at the end of the loop we are going to have something like sets is new sets, right? And what do we want to do here? Well, new sets, we're gonna not override, I think, or maybe yes, override, I think. So yeah, we are only accumulating one vector of results of inputs that gave us this set value, but I think, well, that would work if we only want to accumulate the maximum. Let's implement this for the maximum first, and then we maybe can accumulate like have a tuple of minimum and maximum values. But for now, let's only accumulate the maximums. So what we can do is entry for, and this will also need to be mutable. The entry for this set and modifies blah blah blah, or inserts what are we going to insert? The previous inputs plus this new input. So inserts previous inputs we should probably extract that into a variable. Let's inputs be previous inputs clone. Sure. We extend no, that consumes the self. Although maybe that's what we want to do. No, not really. Extend or concat was the other one. Concat takes, what does concat do? Takes reference to self, single value. Oh, this is not what I want. Not sure. Let's clone and inputs push the input W. This will need to be mutable. Or insert inputs. So it's gonna be moved into here. So modify. Want to take the maximum, right? So let's say value, and here we are gonna do value is a mutable reference, so I guess we can I think we are gonna have a problem here because inputs are gonna be moved or something like that. Is this what I want to do? Is this what I want to do? So what do I want to do actually? If there is no entry for this, I want to insert. And if there was one, I want to override it if these inputs are greater than the existing entry. That's what I want to do. It's not too difficult. So can't we do something like entry is borrow mute what I want? What does or insert give me? Or insert gives me, yeah, a mutable reference. So we can have that. And well, this should always give me something. I actually don't know if that is what this is complicated. Let's express it in a more like dumb but straightforward way. If what do we want to do actually? This if new sets yes, I guess get mute we can do. Yeah, get mute for set is sun value. We're going to do something else. We're going to just insert new sets, insert set inputs, and if it is something, see problem here, set is should take a reference. We should see this later. And here, if our inputs are greater than this value, then hey, this value, what is it? A mutable reference to a vector. So let's just override it. Override it with inputs. Dereferencing borrow, or maybe referencing here. What value input after move? Oh, but I don't want to move. Okay. Does this make sense? I think it sort of does. This was in the case that it couldn't be reduced. So we are going to insert 9 new inputs for each previous value of z, which is fine. And we have these previous inputs. That is fine. So let's actually print something here. Println after block I, there are sets, and will be sets length, and we can actually print this after assigning this. What happens if we run this? Well, it grew to these recognizable numbers that we had before, and then we lost everything. Nice, because this basically fell into this empty if branch, and we didn't populate the new sets. But this seems good already, because these are the same numbers that we have in the first 3 loops from this ugliness that we have before. So that looks all right. And I guess this is 9 times 9, and 81 times 9. So not surprising. Now, if it can reduce z, the logic should be a bit different. Only if z has been reduced, we are going to accumulate that result, right? That's the thing. That's the thing. So if z is less than the previous z, then we are going to accumulate the result. And actually the accumulation of the result is, I think, quite similar to this. The inputs are the same. Yeah, I think the logic is the same. So I guess we can simplify this and say, hey, if you cannot reduce z, or this, or you can reduce z and z has been reduced, then we do this accumulation. Does that make sense? Is this previous z a reference or something? Yes. Does this work? Whoop, whoop. We're getting something. We're getting something a bit explosive. Huh. We're getting too many sets, I think. I think I did the condition wrong, probably. So, if we can reduce z, think I did this Boolean condition wrong. So what I want to do is, okay, if you can reduce set and this, right? Or you cannot reduce set. I don't know if that's the same as that we had before. But we have too many sets. What if we run now? No, I think this is the same logic as we had there. Okay, and are we actually reducing set then? Here we should only, like in the block number 3, or the 4th block, we should only be putting set like new, smaller sets than we had before. And presumably, since those sets will be like division by 26, it should also reduce the number of sets that we see. So I don't understand why this number increased from here to here. That is weird, I think. So can reduce set will be true there, and only when set has been reduced we should accumulate. Can I maybe debug that on the 3rd block? Print some things. It's really weird that set. What's happening there, right? I would like to maybe see how the value of set gets reduced in the 3rd block. How do we do this? Yeah, it looks kind of weird what we are doing. Because definitely in the last ones, this should definitely be going down. We can maybe do, like, to have an idea, because we have like, okay, like 500,000 set values by the end. Here it got reduced actually. You can see that. And here it also gets reduced in number. So that's fine, I guess. Did I have a stupid error when doing this accumulation? And actually, there is something that is kind of dumb, I think, when I join those two conditions, which is that Actually, sort of want to separate those conditions now. Let's say if I can reduce Z, it's gonna be one thing. Else, let's put what we had before. Let's actually, I also want to copy this condition. Okay. So I'm pretty sure about that else branch. Now, if set got reduce, simply do the same. That is, I don't think that this is different to what I had just now. I think it is the same. Yes, it is. But one of the things that's weird here, I think, is that if we cannot reduce Z, then each of these inputs, it is the previous inputs, each of the inputs will be different. Oh, but I guess the sets are what's important here. So this was all right, correct. Okay, let's go back. The logic here is not too bad. We have this. Okay. I want to print basically what are the different set values on after the third block and after the fourth block, I think. So, and it's actually only iterates up to there. So if I run now, it's going to only, do the first 4 blocks. How are we going to do this? Because again, iterating these hash maps gives us annoying order. So let's actually accumulate this. Let's sets vector be new sets iter collect sort this thing and then just print it, or maybe just do for what do we have here? Set and inputs in sets vector. We're gonna print line and say block number I. We have what? The Z and the inputs, I guess. And then do a print line. Well, I guess we already have this print line, so that's fine. So block 3, we have this like 10,000s of things. Which, is this correct? I sort of don't feel like this is correct. Lots of block 3. Oh, and then we have the small ones. We're not filtering? Yeah, no. We should only be keeping these small ones for sure. So what's happening here? Set should be less than the previous set. Can we know what the previous set was? That's really bad. Can I print? So inside of here, so this gave me sort of an idea of what's going on. We're not filtering. So if this is true, let's do it maybe in here. Print line, or something like this. Block. We're gonna have the previous set, like the set goes to previous set to set with inputs this thing. Okay. They are not being reduced that much, just a bit, but we care about these things. So can we do actually like a integer division to take that? If we do this number, oh, we actually have the IRB from before. Divided 26. This 2 to 3, yes. We can actually do this pretty exactly, I think. If set is equal to previous set divided by 26. Like, what if we are very exact about that? Now we should only see these reductions that are much more important. Yes. That makes more sense. Let's clean this. This is a bit hard-coded, but yeah, I'm okay with that. This really depends on the shape of the input, and we know the shape of the input, so that's right. We're also doing 26 over here, so yeah. Let's not only take 4, let's do the whole thing and see what happens. And yes, after the block 13, there's only one value for set. That's nice. And it should be 0. And it should have the inputs that we want. So let's do this. Let's do an assert EQ that sets length is 1. Then what we can do is well, we can do that, and what else? Well, we're just gonna get basically the 0 and I guess reference to 0. And this is a vector, right? So we can do just join these numbers, I guess. I guess we can do, hey, let inputs be sets. Do we have a first? No. Do we have values first? Oh, this is an iterator. Yeah, sure. Next, unwrap. We have already checked that it should exist, so it's good. And then we're gonna just print line inputs. So we cannot join like this, right? No. Yeah, let's collect. Now let's iter map into the string and join. Collect into a vector. What's your problem with this? Turbofish. Sure. Oof, that is ugly. But is this the correct answer? And I think it is. If we copy this. Yes, indeed, it is. Okay, that wasn't too bad. That wasn't too bad. We have the correct answer for the maximum model number, and we also need to accumulate the minimum. So there is man, this is quite ugly. What do I want to do here? I guess we can maybe extract this. Yeah, let's put this into a variable, this hell. Max model number. Okay. And actually, can't we do something like create a number from its digits? Rust number from digits, something like that, I guess. Oh man, the screen is so bright. Maybe because it's midnight. I should get to sleep soon. So okay, this is fine. Not very pretty, but fine. We can print this into here, I guess. Sure. So can we also accumulate the minimum inputs? That shouldn't be too difficult, I think. This said values. But what if we don't do this? Can you infer what's needed? Seems it can, okay. And it also runs fast in debug mode, that's also nice. This I is not used, so we can get rid of that. We can just iterate. And, well, what we should do is instead of doing this, we are going to if there is none, the maximum and minimum are going to be the inputs. And as this is a vector, that's also going to be a problem because we need to clone this thing, I think. So something like inputs clone inputs. Oof. Sure, but wait a second. Sum, min, and max inputs, and if inputs is greater than the maximum, what is max? Is a mutable vector. Okay, so we override the maximum. I guess we can say else, right? Because if it's greater than the maximum, then it cannot be at the same time less than the minimum, probably. So else if inputs is less than the minimum, then minimum inputs. Okay, it's not complaining. I think there is an error somewhere. Yes, this said, oh, this. So, no, this is empty. This is fine. What's the error? Hash map, found hash map of these. You could not infer the thing very nicely. Does it help if I tell you that this is a tuple? That thing looks very strange. Oh no, this should be, yeah. Tuple of vectors. Wow, yes, I guess. Oh, then it should be able to infer if here I pass something like this. To be honest, I'm not entirely sure because the empty vector, when we ask if something is less than that, I'm not sure if the logic is gonna be good or not. What are you complaining about this? For the tuple? What the hell? Oh no, not previous inputs. Right. All right. The previous inputs now have a maximum and a minimum. That sucks. That kind of sucks. Yeah. let's go back to only having the maximum, because I think that was not a very good idea. Having the same hash map for both. If we run now, we should get the answer of the maximum. That's correct. I think maybe we should accumulate into 2 different hash maps and have some repeated code, but I think that's fine, probably. Yeah, let's do that. So instead of sets, we are going to call this max inputs. And this should be that. This new sets is going to be new max inputs. Okay? And we do that. And then we just copy paste like champions. But instead of assigning max inputs here, we're going to assign min inputs. And what is min inputs? The same thing. The same thing. And this will be new min inputs. We iterate min inputs, of course. Oops, I screwed something there. Not a refactor, just a change. We're gonna iterate over this, sure. And here the logic is gonna be, hey, if the new inputs are less than the previous ones, we override them. And that's it. We are gonna do, what if we inline this thing? Super long line, horrible. Let's call this thing max inputs, actually. Yeah, max model numbers. Oh, max inputs has the same name as this. Well, that's fine. Let's do the same for the min inputs. Gonna assert this. Min and max and min should both be of length 1. I think. Actually, I don't know. I don't know if the minimum inputs are of length 1. Oh yeah, because we should reach 0, I guess. Well. Let's rename this. And we're gonna print both max and min. What happens if we run now? Well, the maximum is the same as before, yes. And is the minimum the same answer that we have here? Yes, it is. Okay. All right. So this has repeated stuff. What you gonna do? Yeah, it is pretty repeated, to be honest, but they are 2 different things, the max inputs and the min inputs, and we keep track of them separately. We could extract this into a function or something, like, sure, because the logic, like, the only thing that changes when we're accumulating the inputs, the only thing that changes is basically this condition. Right? Yeah. well, we can think about that later. This amount of repetition for me is quite acceptable compared to the mess that we had before. So let's actually remove the mess that we had before. All of this goes away, because now we have actual answers that make sense. This debug flag should also go away, because yeah, we don't need this. Bye. This we don't need. This, well, we don't need. Should still get the same answer, which runs quite alright in debug mode, so no optimizations are needed. And okay, let's look at the diff actually. All of this mess to the left, to the right, it went from 469 lines to less than 200. That's pretty good. That is a win I can take. Definitely, yes. Okay, so let's add these changes. We definitely want that. Okay, some else that we probably want is when we are running this, we are returning all the, like this code is pretty generic, and I guess that's all right. It's like this code doesn't know about the shape of this input, but this code does, and it makes some assumptions about that. And I think that is all right. Yeah, I was thinking that maybe we can just pass the value of initial set here, and this run earlier program could just return only set. But I mean, it's like, it's fine that it's generic, that this doesn't concern about like the monad program itself. And actually, I think I didn't use the M word. Yeah, no, I didn't use that in the program at all. That's very nice. What else do we want here? This. Sorry, what I was thinking of is what else could we maybe improve in this other code, the parsing and the interpreter. The interpreter has this quite repeated code for all the binary operations, so I think that's probably something that I want to refactor. I want to say something like, yeah, because these are all have the same shape. So instead of saying that, what I want to say is it's either an input or it's going to be an operation between op var and an operand. Okay, and then we are gonna copy this yank, and let's have an enum op that is just these things. Okay, and what you don't like about this, doesn't implement debug. Sure, but you can also not implement debug, and that will be fine, I think. Okay, so with that in mind, then, well, we need to fix the parsing. So here we're gonna match this thing, and yeah, we can do let's op be this and have this, and then we are gonna return an instruction of type, this is basically a binary operator with this op with A and B. And that takes care of the parsing. And now the juicy part, the interpreter, we can be more generic here, I think. Yeah, we have some conditions for div and mod. Sure, but I think that those conditions can be put, like what is true for everyone is that we want to do the value of B and this kind of thing. So I think this can be pretty much extractable into something. So if it's an operation of op A and B, we are for sure gonna do A and B value. Okay, and then do something like, hey, val, or let val be match on OP. Can you, oh, I don't know why I don't have autocomplete on these things. I should check to see how the editor is supposed to work for this kind of things, but okay. Okay, so now, if it is each of these, we will end up doing vars equals val equals val, and here I think we just want to do A val plus B val. Mul is gonna be the same basically. Div, well, it's gonna have the assertion, I think. Although I actually don't know if the assertion is needed at this point, but let's put it just in case. Because, yeah, we are not triggering any assertion error, so I think it's not needed. For mod, it's gonna be this. Yeah, and these two ugly assertions. Yeah, I'm pretty sure that it's not needed. And then it's gonna be this. This is B val, and this is A val. Okay, and that's it. Okay. This, I think, should work as it did before. Or we get into an infinite loop. Beautiful. So we screwed something up, that's for sure. A val, B val, A, Yes. Is this value? Sure. We are managing all of this. Sure. What did we break? It's weird that we broke something. Are we getting... yeah, I don't... Do we get to run any blocks? Println running block. You don't even need the block number, I guess. Yes, we are running the blocks, but they are now taking much longer for some reason. So we definitely introduced some gnarly bug. But what is it? I'm glad that I had added the other changes there. So, okay, we did have this, where we were assigning this, plus this. We changed it to this. Oh, here's a plus where there shouldn't be one. That's surely going to cause some problems. So if we run now, yes, we do get the answers. Okay, so I think here A and B are, I'm tempted to say like A var and B is an operand, B operand, and rename these to just A and B to make these things that are used more often a bit shorter. And I'm also tempted to just remove these assertions that are not being used. And yeah, this thing becomes just much more terse. What else? I guess... Oh, yeah, this value thing is now only used in here, and I really don't like that this thing extracted into a method of the operand, so I want to inline it. Actually, can I inline it like this? Oh, look at this. How this inline went. Well, it called this reference, we call it this, and ref. This is something that I'm not used to seeing, but inline it. Wait, what? What happened there? Oh, B is, oh, this refactor was quite weird. Like, please inline this thing, get rid of this, replace this with a more normal match, please. Okay. Yeah. Does this run? Yes, it does. Okay, so I guess actually this value, I guess actually what we can do is, you know what, I'm tempted to do something maybe a bit clever here, but I think I will like it. Puts all of this into a block. And yeah, just assign this. And now a var can be just called A, B operand can be just called B, and everyone is happy. So vars in A, we are assigning well, the value of A, then computing the value of B, and then doing this thing. That is much better, I think. Should still run. Yeah. That's pretty good. There's maybe about, let's see the parsing. Oh, this filter is no longer needed. We had this only when chunking the input and inserting blank lines there, but we don't need that anymore. This looks all right to me. Parse var. Yeah, this parse var. I was thinking of these variables we are basically using as indexes. So here, let's check these changes before adding them. Yeah, I think they're pretty solid, I think. They made the code a bit shorter, but they also make sense. Like they remove some of this repetition here. And yeah, the logic on the interpreter is much clearer, I think. So let's add these changes too. Or should maybe I commit this separately? Yeah, I'm tempted to do that. So yeah, let's commit this first. Refactor. Or actually, maybe I should commit this. And amend it to the previous hellish commit. I think I'm probably going to do that. So let's do git commit amend into the previous one. So just add the 24 solution. And we would be losing our messy solution in the history. I don't know if I want to keep that. I mean, it was fun. the code looked quite funny. I don't know what happens if I abort a commit like with Control C. Let's see. I think nothing wrong happened there. Just got aborted, as one would expect. Yeah, let's actually leave the super messy solution in the history. And let's commit this refactor. So refactor day 24 solution, refactor day 24. Use a generic loop over each block of the program, of the input program, instead of the mess that it was before. Okay. And now what we did was improve the the parsing and interpreter, so I'm going to add those changes, but I also want to try something here. So the vars, these vars, we aren't really referencing them anywhere except when we are parsing, only when we are parsing. And then we are just using them as indices for this array. So like this, indexing the array with the variable a. So I think this actually doesn't want to be an enum. This can be just a struct with an index. We can give it a name maybe instead of, maybe we can just not have this. Oh, well, maybe, operand can be, I mean, we could have this be just the usize, right? Yeah, why not? So basically this have the index of the variable, and that's it. So now this thing, parse variable, will return an index. And it will just return this, which is the same thing as saying w x y and z iter position of this var and something like I mean, this is the same, but I think this is more readable. So let's leave the match. Okay, yes. And now that where we were using var, we are converting as usize, but I think we don't need that because these are already usize. And I think that should probably work. Let's test it. And it does. Okay, that's also a nice simplification. We don't need the enum, the var enum with all of those derives and blah blah. It's like it's just an index. Yeah, the variable is just an index. Maybe we can call it like var index, but I mean, is it necessary? No, just let's say that the vars are just indices into this array of vars, and that's fine. Because after that we were just yeah, just using those things as accessing them with indices instead of by names. So I think that's fine. Okay, so I think that's more or less it for this code. I feel pretty good about the shape of it now. We can maybe rearrange this a bit to have the instruction above all, because it's like the more general thing that we care about. Sure. This is fine also. Sure. And this code I think is pretty much okay. There's just a couple of things that I would like to, minor things that I would like to do, but let's simplify parsing and execution on day 24. Okay. So maybe I think this warrants a comment. Say, hey, split the program into blocks which consist of a single input instruction and its following instructions until the next input. Sure. And I also want to leave some comment with this sort of pseudo code analysis that we did. I don't know if I want to try to extract this thing, this loop, into this loop into what? What I was thinking of? Yeah, into an accumulation, or not the accumulation, but have basically two different loops, for one for the maximums and one for the minimums. It's like could be or we can do that, or extract this, which is just creating this variable to no, but I think those actually that might be a good idea. It might be a good idea. So what if we extract this? Can we do so? Extract into function. What am I going to do? Oh, you are receiving this as a mutable boolean. That's close enough, I guess. Let's call this thing can block can reduce set. I don't know. Now, let's not extract this thing that we're only calling once. It doesn't make much sense. We are just, this is clear enough, I think. What I may want to do is these two things, which are basically almost the same. These two things, maybe I could extract. Let's see what the extraction does for this. Quite a bunch of things. Max inputs, blocks. But it's kind of close enough. We have a block, that's for sure. A block, I'm sure we do. Can reduce set, probably also once, but this is the return, I think. Oh, but we also need to iterate the previous max input. So now, you know what? Let's leave it as this with all of the repetition. That's fine. I don't want to dry the code much more, dry up. About this pseudocode, where could be a good place to comment on that? So I guess here, when we start this loop, each block of this program is behaves like this pseudo code, and that didn't work. Okay, so set, I don't think we need to declare. Let's WP the input. Actually, it doesn't need to be pseudocode. It can be Rust code, I guess. Yeah, WX. Yeah. And here's this thing. We also have that condition if Z1 is less than 0, it's negative, then we also have set being divided by 26. C1 and C2 are constants and are different in each block. So yeah, we also have this condition that X, when if we look for this, yeah, there are 7 of these. They are always greater than 10, the numbers that we add. So there are 14 blocks in total, and of them and 7 of them have negative C1s. Some of them have C1s C1 greater than 10, so the condition of X different than W is never So the condition is always true. Oh, I tried to wrap the pros, but it screwed everything. And it keeps screwing the thing. Let's do a manual wrap. So the condition is always true. Yes. Variable w, the variables w, x, and y are all local to each block. Only the variable z has a value that persists between blocks between blocks, and we want that to end at 0. Is always true, and those blocks increment z by 26-ish times, and the other 7 blocks have a negative C1. In those ones, we need to make sure to have x equal w. Sure to and those blocks increment set by the other 7 blocks have negative C1 to make sure that to have x equals w, so that z doesn't get bigger and instead gets reduced by 26 times. Gets rounded down 26 times, yes. So that's basically what this thing does. So it's true no matter the input w, and those blocks increment blah blah blah. The other 7 blocks have negative C1. In those ones we need to make sure that w x equals w, I would say, by choosing the correct w input. so that set doesn't get bigger and instead gets rounded down 27 times. This code picks the correct W input values for set to go, for set to eventually go down to 0. And that's it. That's a pretty lengthy comment and explanation, but I mean, this was pretty involved, so I wanted to leave it like documented somewhere. And I think that is pretty much it. I commit this, which is just comments. Add some documenting comments to day 24. And yes, that is everything that I wanted to do, I think, for this solution for day 24. It was pretty fun to implement this, and I learned, I think it was a nice lesson about not trying to plan everything ahead, and instead just trying to do whatever, the simplest thing that comes to mind, the naive approach. Then seeing what fails, trying to understand what fails, and iteratively fix that until you have something that works. And it actually, that approach, I know that approach is the thing that makes sense, but many times I forget to do it, and I fall into like over-analysis and analysis paralysis. So that's what happened more than 1 year ago when I tried this, and now it works much better. So I'm glad for that. And well, if you reach this part of the video, I think you have a lot of patience, and I thank you very much. And see you later, I guess. Bye bye. And